Good everyone. Today we'll be looking at how to differentiate inverse trig functions. How to differentiate inverse trig functions. We have learnt or we have done a lot on trig functions. And now we want to look at the inverse of the trig functions. So the first question I have here is, if y is equals to sine inverse of x with sine inverse of s, find the y over dx. Find the y over dx. That is the first question we have here. So let's look at how this is done. What will be the solution to this? The solution will be the first thing that if we are saying y is equal to the sine inverse arcsine of x, indirectly you can requote this statement or you can restate the statement as x is equal to sine y. You can do it this way, as x equal to sine y. Because if I'm telling you that y is equal to sine inverse of x, I'm indirectly telling you that x is equal to sine y. That's what I mean. That's what I'm saying. It's just like it's inverse of each other. It's something like a reverse of each other. Remember, if we have something like this, if I'm telling you that if I say something like 0.5 is equal to sine x, x is equal to the sine inverse of 0.5. The same way, I'm telling you y is equal to sine inverse of x. It means that x is also equal to sine y without inverse. So differentiating both sides, the x related to y, we're going to have differentiating related to y, we're going to have cos y. That's why we have it, cos y. Then you can say it's over 1. Then we're looking for the 1 over the s, not the s over the y. You want to take the reciprocal or the inverse of both sides, bring in y up, you bring your s down, bring the y up, then you bring the s down. The same thing, bring this one up, then you bring this cos y down. So the 1 over the s will be mine, that will be equal to 1 over cos y, 1 over cos y. But the problem is, there is no y. Y is not the function of y here. So the answer cannot be a function of y. The answer cannot be a function of y. It's not proper. Because the question is a function of x, the answer should be a function of x. So how are we going to do that to get the answer to a function of x? We're going to recall something from trig identity. It's all called trig identity. Trig is an abbreviation for trigonometry. Trigonometry. Now, trigonometry has identity of number 1. Now, we're going to look at what is the identity that relates. What identity relates sine and cos together? One of them is that cos square y plus sine square y should be equal to 1 from trig identity. You can first say cos square theta plus sine square theta is equal to 1. So as far as this theta or y is acting as an angle to the cos or sine, the identity is valid. I can say cos square x plus sine square x is equal to 1 is valid. I can say cos square a plus sine square a is equal to 1. Anything can replace that theta. As far as this theta and this one, they are the same thing. If this one is b, this one will be b, this one is c, this one will be k. So what is here and what is here, they are the same. The identity or the relation is valid. So from here, we can opt out this cos y by making cos the subject of the formula. Let's go. Cos square y will be equal to 1. If this one cosine this side plus cosine this side, which is to minus sine square y. That's what we're going to do. Then, the next thing we're going to do, we're going to take the square root of both sides, so that this square will go programming for cos y, not cos square y. You also take the square root of this other side. You take the square root of this other side. Then this square root will cancel this. Our cos y will be equal to the square root of 1 minus sine square y. But from this place, it said x is equal to sine y. You're thinking, but x is same thing as sine y. We can say this one is same thing as the square root of 1 minus sine y. Everything is power 2. It's possible. It's possible. If I have sine y, everything is power 2 is same thing as sine square y. So that the answer can, so that this can be cos y is equals to the square root of 1 minus, since, okay, or let's bring back our question first, so we know what we're doing. We know what we're doing. Remember the 1 over the x, the 1 over the x is equals to 1 over cos y, and cos y is same thing as what? That is square root of 1 minus sine y squared. And s is equal to sine y. So you can now say times 1 over 1 minus s squared. Because sine y is equal to s squared. You put s here, you have s squared. It's a final answer. So let's look at a question like if y is equal to sine inverse of 2x, find dy over dx. Find dy over dx. So you can say 2x, same thing as sine y, then you come from that angle, then you get the answer. There's another approach I will also show you. If you still use the approach, you're still going to get the answer perfectly, without any delay. So let's look at something here. Well, let's come from chain rule. Okay, let's go from chain rule. Then you can say let 2s, since it's not just equal to u, from chain rule, let 2s equal to u, so that our du over dx will be 2. Our du over dx will be 2. And we can say the equation will now be equal to sine inverse of u. Because if let 2s equal to u, then our du, if you differentiate u, we are going to differentiate u equal to 2. Then what about dy? What about dy over du? Dy over du is not equal to what? We're going to differentiate this over to this u. Just as we differentiated this to get this answer, if this s is not u now, what will be the answer? The answer is still very the same. 1 over the square root of 1 minus, but this s will not be u squared. Remember, this one is s, differentiate it will be the square, 1 over the square root of 1 minus s squared, frees u. You also replace the s with u, but it should be dy over du, not dy over ds this time. Then the next, your dy from chain rule over ds will now be equal to dy over dx. dy over du times du over dx, and that will be equal to, what is dy over du? 1 over square root of 1 minus u squared times, what is du over dx? 2. So 2 times 1, that will be 2. The square root of 1 minus u squared. So now give us 2 over the square root of 1 minus, what is u? Our u is the same thing as 2x. So we replace it with 2x and square it. That will give us dy over dx to be equal to 2 over the square root of 1 minus 4 squared. That will be the final answer to that problem. 2 over the square root of 1 minus 4s squared. So please, that is just question 2. I don't know if we can add another question to this. Okay, let's look at another question. Let's look at another question to this. Let's look at another question. Let's now have question 3. If y is equals to, let's say, the sine inverse of 6x, what will be the y over dx? What will be the y over dx? What will be the y over dx? For that, you can try that up to see if you can actually solve that problem. The y over dx will not be powerful. Now let me give you a shortcut to get the answer directly without going to this workings. Let me give you a shortcut to get the answer directly from the question. Look at the shortcut. What we are going to do, we already know that if y is equals to, we are aware that we should be aware that if y is equal to sine inverse of x, then dy over ds will be equal to 1 over the square root of 1 minus s squared. You should be aware of this, it's very important. Then if you now have y to be equal to sine inverse of 6x, your dy over ds must be, look at it. The first thing I'm going to do, look at this one. Let me explain this formula in another way. This one is constant. Remember we got it from when we're doing cos Square s and sin square s, then it will be 1. That is the one we are having here. But what about this other one? That other one can be tend to be the differentiation or the derivative of s. The derivative of x. If you differentiate x, that's when you are going to have that one. That's when you're going to have that one. That's where that one is coming from. You can take it that way. So that if you want to get this numerator, you must differentiate what is acting as an angle to the sine inverse. For example, now, I want to get the numerator of this question. I'll differentiate this 6s. Differentiating 6s, because this 6s now acting as s. That will be 6 over the square root of 1 minus. Am I going to use s squared? No, I'll still use the same 6x. Then before I will now square it. So that everything will now be 6 over the square root of 1 minus 36s squared. Simple as ABC. If you try that method, you see what I'm doing. Okay, let's try that question. So that's what I'm trying to say. Let's try that question. You see it. Then number 4. Let's repeat this question too. If y is equal to sine inverse of 2x, it says the rho over the x must be differentiate 2x. You have 2. The square root of 1 minus what I'm going to do, not s squared, we use 2x. But 2x is what is here. So you square it. This one gives you 2 over the square root of 1 minus 4s squared. Answer. This answer is this. Are you not the same? They are the same. So this is part of the stuff you need to get, you need to grab. So we can say generally, therefore, if y is equal to the sine inverse of a function of x, dy over ds will be equal to the f prime of that function divided by 1 over the function of x raised to the power 2. You can say this is very valid. This is very valid. Let's look at question 5. Look at another question 5. If y is equal to, let's say, sine inverse of 1 plus 3x dy over ds will be equal to differentiate 1 plus 3x, differentiating 1 is 0 plus differentiating 3s plus f prime of s means the remember we were doing y prime. Prime of this means differentiate it. Differentiate this, what you have here. Differentiate this, what you have here. Differentiating 1, you have 0. Differentiate here of s, 3s, you will have 3 over the square root of 1 minus 1 plus 3s squared. That was 3 over the square root of 1 minus 1 plus 3s squared. So you can decide to open the bracket and decide to leave the answer this way. Try to leave the answer this way. But I'm going to put the bracket for you so that you see how to open brackets. So you see how to open brackets. In the I'm going to do it in a very short way. Or let me just use a very long method to do it. So we have 3 over the square root of 1 minus because of time. You can do this way. You can say 1 minus 3x. You can do this way. You can do it this way. I do this way. This 1 minus, that is plus 3x squared can be equal to 1 plus 3x times another 1 plus 3x. 1 times 1 will be 1, 1 times 3 will be 3x, 3 times 3x times 1 will be 3x, then 3x times 3x will be 9x squared. That will be 1 plus 6x plus 9x squared. I do it this way, but I'm not going to do that. I'm going to do it on that short way to expand a binomial that's having power to be 2. Look at how to do it. What we are going to have will be this 1 raised power, this 2 that is there, that's 1 squared, plus that sign plus 2 times 1, that's 2 times this power times this first 10 there, times 1, times this second 10, 3x, then plus 3s, then raised to power 2a. Look at how it's going to be 1 raised to power 2 plus, because if it's minus, that will also be minus, plus 2 times 1 times 3s, then plus, not because this plus, so the third term will be positive, plus 3s raised to power 2. That's what I'm going to be having. So that the final answer, you take this sheet, the final answer will be equal to 3 over the square root of 1 minus, that's 1 minus 1, 2 times this time, that is 6x, 2 times 3, that is 6x, plus 3 square will be 9, and s square will be s squared. Remember that? Remember what we got before? In this place, it's still the same thing. Therefore, we'll be having the square root of opening the bracket, like minus times y is minus times any plus will be minus. So 1 minus 1, we are going to be having 6x plus 9x squared. That will be the answer to that. You can also say this and this, 3 is common, and so factor 3 is, but you cannot bring out the 3 because of the square roots. That's why you should not do the answer that way. That's why you do this minus, so this is also negative. Both of them, they are negative. Sorry about that. Both of them are negative. Negative 6, negative 9x squared. Please, we're going to draw the continue here. And you can also try this. You can also try this. Let's see number question 4 now. If y, question 4b, if y is equals to, let's say, sine inverse of 4x over dx will be equal to 4 over the square root of 1 minus 16x squared. You can do more from your first book. God bless you. See you guys. Yeah. Hello, good everyone. We are still on inverse trig functions. And today we are going to be looking at if y is equals to the cos inverse of x and not, we did sine inverse before, and we are doing the cos inverse of s. What will be the y over ds? So the first thing I already told you guys, we have y to be equal to the sine inverse of s is equal to sine y. In the same way, if y is equal to the cos inverse of x can also be called cos y. Now differentiating x related to y, we are going to be having minus sine y. As simple as that. So please ensure you watch this video to the end. Don't skip any part of the video. And ensure you subscribe and share to others. So that everybody can begin. Because this is an avenue and a platform to learn. It's all about education, science education and per se. We are doing chemistry, physics, maths, and everything. Please will join soonest. So thank you. So we're going to have differentiate cos, we're going to have minus sine. Then dy over ds will be taking the reciprocal of this side. Remember this one is over 1, but we don't put 1 because there's no need of that one. But if we need it, we bring it. So we do this, interchanging, we're going to have minus 1 over sine y. That's what we'll be having. But we cannot leave the answer as a function of y if the question is a function of s. So we have to recall that from trig function, cos y, that's cos square y plus sine square y is equals to 1. I need to say that cos square y plus sine square y is equals to 1. So the next thing, our sine, we're going to make sine formula now. Our sine square y will be equal to 1 minus cos square y. So that we take the square root of both sides, this will cancel this sine y will be equal to the square root of 1 minus cos square y, 1 minus cos square y. Then go to the question and replace your sine y with 1 minus cos square y. So divide over the x will be equal to minus 1 over the square root. Remember sine y should be replaced by, since sine y is the same thing as this, we replace with this. Now 1 minus cos square y. That's what we're going to be having. 1 minus cos square y. But cos y is same thing as what? Same thing as x. So that is the same. So anyway, see cos y, you put x there. So we don't have 1 minus 1 over 1 minus. So anyway, see cos y, you put x, but this cos y is having square. So that will also take the square. So the answer will be minus 1 over square root of 1 minus s squared. Minus 1 over square root of 1 minus s squared. Or you can also say, or if y equals to the cos inverse of a function of x, dy over dx will be the f prime of that function divided by negative, actually. The f prime of that function divided by 1 minus the function of the square. It doesn't put it this way. It's also possible. Let's see, the f prime of the function is here, then 1 minus the function, then you square it. Now let's look at an example. Let's say we have something like y to be equal to, let's see, cos inverse of 6x. Cos inverse of 6x. So if you have to apply this relation for this, you said if y is equal to cos inverse of the function of s, that's how it will be the f prime of the minus the f prime of the s all over the square root of 1 minus the function of s squared. If you try for this, what's the f prime? The function of s is x. Relating the x, you're going to have 1. This is s squared. You can do that one. So I'm going to be using this formula. The y over the x will be equal to the function of s here, the function of x is. Okay, let's just put it where. For this question, our function of x is 6x. Then if you differentiate it, you're going to have 6. So using this formula, the answer will be the y over the x will now be equal to minus 6 over the square root of 1 minus 6x squared. So that will be equal to minus 6 over the square root of 1 minus 12, that's 36 x squared. That's what we want. Let's say number 2. I think we'll look at 2 examples here. Then, so if y is equal to, you can say cos inverse of 10x dy over dx will be equal to, what is our function of x here? Our function of x is what? 10. So we have minus f prime of x, means differentiating the function of x. So differentiate this function, differentiate 10x, we have 10 over the square root of 1 minus 10s, then you square it, that will be minus 10 over the square root of 1 minus 10 squared is 100 s squared. That will be the answer to that. So please ensure you subscribe to this channel and share the video. God bless you. See you guys. Inverse trig function. And today we're going to be looking at if y is equal to tan inverse of x, or tan. If y is equal to tan inverse of x, what will be your dy over dx? What will be your dy over dx? So ensure you subscribe to this channel. Subscription is free. And don't skip any part of the video. Don't skip any part of the video because you are going to gain a lot from it. Don't skip any part of the video. So let's look at this. I already told you, I'm telling you why it's going to tan inverse from the inverse equation we have been doing. If y is equal to the tan inverse of x, s should be what? Tan of y. You can put it that way. If y is equal to the tan inverse of x, you can say s is equal to tan y. Now the relative both sides, related to y, we're going to have sec square y. We're going to be having sec square y. We're going to differentiate tan, we're going to have sec square. We're going to be having sec square. So dy over dx, bringing y up and bringing dx down. Bring this thing up, bring this dx down. Remember this one can be said to be over 1. Bring this one up and bring this set square down. Then you're going to be having this. But look at it. The answer is a function of y, but the question is a function of x. So you're going to make sure the question is a function of x. In the sense that we can say, but from trig identity, we are using from trig identity, it's very good to say 1 plus tan square y is equals to sec square y. Or we can say sec square y is equals to 1 plus tan square y. Yeah, you see, sec square y means 1 plus tan square y. It means the same thing. So, anyway, you can say, okay, the answer is 1 over ds is equal to 1 over. Since we have to use sec square y now, we can use the equivalent of that square 1, which is what? 1 plus tan square 1. Can use that. In the sense that we know that, but we know that tan y means what? What is not tan y? Tan y means x. That's the meaning of tan y. Then the one my dears can set to be 1 over 1 plus tan, but this tan is carrying square. Remember, I can write it not this way: 1 over 1 plus tan y, everything is power 2. Can write it that way, so that we can say, okay, 1 plus tan y is x, everything is power what? 2. So if you differentiate tan inverse of x, the answer will be 1 over 1 plus tan 1 over 1 plus x squared. You can also say, if, or you use this approach, if y is equals to the tan inverse of a function of x, dy over dx will be equal to the f prime of that function 1 over 1 plus the function of x itself. Remember, f prime means differentiate the function. That's what it means. Okay, you can say, okay, number 1, if y is equals to, let's say tan inverse of 5x, find the y over dx, find dy over dx, find dy over dx. So dy over dx will be equal to, now f prime. What is the f of s in this question now? Comparing this question to this, our f of s is 5x. F prime of x means differentiating this f of x. Differentiate 5x, what do you have? 5 all over 1 plus f of s. Then you square it. Yeah, the f of s is carrying square. Just take a look at that. Is f prime of s all over 1 plus f of square is power 2. Take a look at that. So that will be f of s is 5x. Look at it. Same thing, but f prime of x means differentiating the f of x, which is differentiating 5x, you have 5. And 5x, you replace it back, and you square it. That will be 5 over 1 plus 25 is squared. That's what we'll be having as your answer. Number 2. You can say number 2, if y is equals to, let's say we're having tan inverse of x over a. Let's say you're having the tan inverse of x over a. Find dy over dx. Can be x over 3, x over 2, x over 4. Where a is a constant number. Solution. Now let's use this formula. Now what's the f of x there? Our f of x is what? Is x over e. That's our f of x. And the f prime of x will be equal to, look at it. This can also be 1 over a times x. This also means 1 over ax. That's what it means. If you differentiate 1 over ax, just as you differentiate 2x, that's will be 2. If you differentiate 1 over ax, that's will be 1 over a. The same way. The thing will still be 1 over a. So if you differentiate this x over a, you differentiate only the s out. Since a is a constant number, a is not a variable. As when a was a variable and x was a variable, you will use quotient rule to do it. But since a is a constant number, only x, which is the numerator, is a variable, you don't differentiate. But if x is the denominator and a is the numerator, you cannot do that one. As far as your numerator is the variable and the denominator is constant, you can use the ratio of the regular function to run it. Relating just x, you're going to have 1 then over a. Just as if you also call this 1 over a x. Relating 1 over a x, relate only the s out, you have 1 times 1 over a, it will be 1 over a. That's how you appreciate that. It's a very short way. The next, you can also use quotient rule, you still have this, but in a very short way, you just relate only the s out, then you have this. The next, dy over dx will be equal to the f prime of x, which is 1 over a, over 1 plus f of s squared. What is f of s? S over a, then you square it. That's what we're going to be having. So that we'll be having 1 over a over 1 plus s squared is s power 2 is s squared, a power 2 is a squared. So next thing we're going to do, we're going to simplify everything to ensure that there's no fraction in the subtens. So that, okay, let's look at this. We have something like this. So I have to ensure that everything is in order. So I want to make sure there's no fraction in the there's no fraction here. So what is the fraction? Then we have over a. Both of them they are over a. Both fractions are same there. This one is over a, this one is over a. But which a is higher? A squared. So I'm going to multiply both numerator and denominator by that a squared so that the fraction will cancel out. So I'm going to multiply 1 over a times a squared, multiplied by a squared, then 1 plus x squared over a squared. Also multiply 1 with a squared times a squared. So that I'll be having 1 over a times a squared. This will cancel this, only a squared, a will be left there. Then a squared times 1, that will be a squared plus, then x squared over a squared times a squared. This a squared will cancel this. This and this will cancel out, only x squared will be left there. So that will be your final answer to the problem. So that's how you run through that. You can also look at other important questions in this standing marks, the aspect of inverse trig function. We're going to join the course. Yes. So God bless you. See you guys in our next class. Ensure you subscribe and share. Thank you all.